Hi math group. We're going to extend the discussion on discriminants in this video. In the last video, we had established that for a quadratic equation in the expanded form set equal to 0, that the discriminant is the part of the quadratic formula that is underneath the radical. And if the discriminant has certain styles of values, that will relate to how many solutions we get. So to extend this, if we switch it over to a more graphical approach, we can write quadratic functions in this format. F of x equals ax squared plus bx plus c. And that looks very much like this expanded left-hand side of the equation at the top of the page. When we set this equal to 0, which is the rest of that equation, what we're really talking about here, when we solve this, we're letting the y values be 0. We would really be finding x-intercepts. So you could find x-intercepts by solving with the quadratic formula, setting your function equal to 0 and solving. So that means that if we do decide to use that idea and we get a discriminant that's positive, we should have 2 x-intercepts. This is how the association would go. 2 x-intercepts on the graph. If we had a discriminant that was 0, we would have exactly 1 x-intercept. And if we had a discriminant that was negative, that would mean we would have no x-intercepts. So we're moving from just the algebraic manipulation of the equations over to a graphical approach. So let's say we have the following. Let's say we have a quadratic function with a vertex of -3, 8 and a graph that opens downward. What should the discriminant be like and why? So I say it's worth our time to make a quick picture. Some axes, -3, 8 might be up in the second quadrant like that. The graph is supposed to open downward. Maybe something like that. I don't know how wide it is. I only know that it opens downward. The discriminant will, it's associated with the number of x-intercepts that we have. This graph has 2 x-intercepts. And that means that our discriminant should be positive. So to make a statement here, the discriminant should be positive. Since there are 2 x-intercepts. This is a concept question. There's not any real solving to do. We're trying to maneuver our way through the concepts. As a second example, let's say you had a vertex of 2, 7 and a graph that opened upward. What type of a number will you get for the discriminant and why? Similar kind of idea. 2, 7 up here in quadrant 1. This one needs to open upward. It has no x-intercepts. That would be like solving with the quadratic formula and getting no real solutions. And so this means that that discriminant would need to be negative. We'll get a negative discriminant since there are no x-intercepts. As another type of example, this time let's suppose that you have a quadratic function whose graph has vertex -7, 1, that's a positive 1, and the discriminant is negative. Which way does your graph open and why? This time if I try to do a quick picture, -7, 1, hanging out there in quadrant 2, it doesn't tell me the direction. I get this information that the discriminant is negative. And so then I have to remember that if the discriminant is negative, that indicates that there are no x-intercepts for the graph. So if I come over here and I try to draw something with no x-intercepts, and I draw it downward first, I realize, oh, if it opens downward, then I'll have 2 x-intercepts. I don't want that. So it's going to have to open upward so that we don't have any x-intercepts. So the graph must open upward. When you have a negative discriminant, we'll have no x-intercepts, and that will tell you which direction you'll need to open based on the vertex. So I think this one is done. So these are concept problems about the discriminant. I like to ask concept questions. Please let me know if you have questions.